This example comes out of section 8.1, Understanding Logarithms. So in this example, we're asked to estimate the value of a logarithm. Now, depending on what kind of calculator you have, you may or may not be able to just punch this in directly. Even if your calculator only does base 10, the common log, I'll show you later how to do this on a calculator. But for now, I'm not really interested in that. I want to say, well, if this was equal to n, that means that 3 to the n equals 25. Now, 25 isn't a power of 3, but it's awfully close to being a power of 3. So, we know that 3 cubed equals 27, so this must be an answer very close to 3. So, you might estimate that this log equals approximately, maybe 2.8 or something like that. Obviously, it's an approximation, it's an estimate, but something still worth having an answer better than nothing. Now, let's try another one. Log base 2 of 11. Again, let's let it equal n or x or something like that. That means that 2 to the n should equal 11. Well, 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16, so this answer should be between 3 and 4. The exponent here would need to be between 3 and 4, maybe slightly closer to 3 than 4, so you might say that n equals approximately, 3.4. Again, it's an estimate. We could get closer by trying a bunch of numbers and seeing how close we got, but you get the idea. Now, the third one, log base 10 of 50. No matter which calculator you have, assuming it's at least scientific, and whether it's a TI-83, 84, Inspire, any of these calculators will definitely do log base 10. So we could punch this into a calculator. But again, if I'm saying 10 to the power of something equals 50, this exponent must be somewhere between 1 and 2. 10 to the 1 is 10, 10 to the 2 is 100. This answer is somewhere in between, and so you're going to guess, and you're saying n is approximately 1.5 or something, and again, it is a guess. That one you can go directly to the calculator and say, what is log of 50? And if you punch in log of 50, you get an answer of, the actual answer to this one is 1.699, roughly, rounded to 3 decimal places. So, we at least had an estimate that it was between 1 and 2. Now, when it comes to doing the ones above, even if your calculator doesn't do it, you actually have what's called a change of base identity. Now, this is skipping ahead a little bit to laws of logs, but your change of base identity says that if you have any log with any base, so log base b of c, you can write it as log base a of c over log base a of b. Sorry, I think I wrote that wrong the first time. So what does that mean? It means that I could do log base 3 of 25 by just finding out what's log of 25 dividing by log of 3. Because I happen to have a base 10 conveniently on my calculator, I can figure out what this one equals. And I got an answer here of just a little bit less than 3, approximately 2.93. Roughly, which isn't too far off our estimate up above. So again, to try it one more time, log base 2 of 11 is log base 10 of 11 divided by log base 10 of 2. Punch that into my calculator, and I get an answer roughly 3.46. Again, it gives me more decimal places than I can handle, but somewhere in the realm of what the estimate was that we had above. So you can see how having some idea of what a number should look like before you start a question will actually help you determine if you've got the right answer in the end. It's not that you need to know these logs off by heart, but for sure, counting too much on a calculator to do everything for you can be a problem.